Hello guys, welcome to my YouTube channel Decoders Day. Hope all of you are doing great. So today we will be looking into the next video of analog layout design, that is how to do analog layout design of NAND 2 input NAND gate. So launch your Virtuoso in GPDK 90nm and go to new cell view. As we have done library in prior videos, if you have not been through that video, just go through that once, so you will be getting idea how to create library and cells. Okay, so right now we have already created our library by the name YouTube. A cell, let it be of NAND, because we are going to see NAND gate for today. View should be schematic, type should be schematic, open with schematic L. Okay, so our cell view is created. We have reached to schematic window. Press I, browse, GPDK 90 MOS. Okay, PMOS 1, select this one. Symbols, close. Length, let it be 1 micrometer. 1 micrometer. Total width should be 2 micrometer. Okay, and up height. Okay, press Q. Sorry, press I again. Make this sideways so that this one will be just flipped in opposite side. So keeping this same, is a NAND. Hope all of you are aware about how to do the schematic of NAND gate. Okay, go to I. Right now library, keep library as same. Let's cell will be NMOS, and we will be changing this parameter. I will show you the trick to change this parameter. Say NMOS. Okay, right now we are supposed to keep the WS 2 micrometer and length as 1 micrometer. Just select this Q, apply to, select this all. Okay, and length keep it as 1 micrometer, 1 micrometer, and total width should be 2 micrometer, and just apply and OK. Right now you can see it is same has been replicated to this MOS as well. Okay, this W is changed 2 micrometer, L is also 1 micrometer. So for this we have to do again. Okay, this should be, length should be 1 micrometer and total width should be 2 micrometer. Okay, apply. Okay, so next thing we are supposed to do the pin connection. Okay, pin creation. So here create pins as VDD, VSS, A, B and Y. A, B are our input, Y will be output. Okay, direction will be input output. Okay, use schematic, signal type, power. Okay, then height. So place the pins. This is VDD, this is VSS, this is A, and Y will be in between this. Sorry, Y will be here. Okay, sorry. Press U. Okay, we are supposed to delete this one. Go to pin again. We have to create B and Y. B and Y and height. This is B and this is Y. Okay, escape, done. we are supposed to wire it. Press W, choose this terminal, okay. Follow the steps which that I have been following. Just be aligned with me. And one thing, you are not supposed to connect this both okay hinges, whatever you are seeing over here, you are not supposed to connect at same point, because that's why I have connected separate. Okay, two connections I have given over here. This one also connect over here. VSS. This one will be our A. Connect this. This one will be our B. Okay, and Y will be taken from here. And connect the body terminals to source in W. Done. Check and save. We'll see if there is any error. We can see or not. Yeah, it is clean. So no errors we have found it. So if you want to see the characteristics of it, we will launch this in ADL window. ADL edit. Okay, let's keep it 100 nanometer. Okay, keep it moderate. Apply and okay. Here we are supposed to see from schematic. Suppose this is A and this is Y we are going to select. This is B and Y. It is giving that which are the parameters you are supposed to select and see into your output window. Okay, as you can see we have selected A signal, B signal and Y signal. Okay, okay. Once it is done, run this. Yeah, we have got your noise. Here we are supposed to select edit again, make it DC. Sorry, yeah. Here you are supposed to select AC component parameter. Sorry, you can see start from 0 to 100 nanometer. Apply and okay. Again it is given DC. Delete this one. Edit again. It is not giving. Yeah guys, I will work on this, how to do this. Okay, right now we will be just doing the layout of this design. No, Once it is done, press F, check and save, launch our layout Excel, layout, create new, configuration, let it be automatic. Okay, library will be YouTube, cell will be NAND, V will be layout, type layout. Okay, okay. Then we have come to our layout window. So this is layout window we got. Next thing we have to do it from scratch. Okay, so I hope all of you have gone through the video which I have done on how to do the NMOS and PMOS layout design from scratch. So once go through that and get basic idea how the layers used to be fabricated. So I'm going to do it here directly. Select this oxide, press R, okay, escape. So we are going to keep this OD common for this both the transistor. Okay, this NMOS, PMOS as well as this PMOS. So what is the width? It is 2 micrometer. Okay, okay. Before that, we'll set some boundaries. Press C. Let it be 0.0105. It should be 0.05. Along with that, even this should be 0.05. Make this 0.01. X snapping and Y snapping will be given from boundary, but right now it should be multiple of 0.005. Okay, but here we are taking directly 0.005 because precisely we will be doing this. Okay, okay. Select oxide, press R, done. Select this, press Q. Here height will be defined as width. Okay, make it 2 in terms of micrometer. The entire things whatever we are going to do, it will be in terms of micrometer. Press OK. Okay, done. Next, draw the poly, press R. It should be 1 micrometer length. Done. Q. Make width will be defined by length. Okay, 1 micrometer. Sorry. Yeah, it is 1 micrometer. Let it be 1. Apply and OK. Just copy this thing to here. So we are going to see what should be the spacing between two consecutive polys. Okay, just save and run our DRC, Assura DRC. See here, you can see library name, cell name, and we will be layout. Just press OK. Yeah, just ignore this first error. Oxide must be covered with unimplanted P implant. Here we have given too much spacing. We just adjust this poly. Okay. Want to say actual, smooth this little bit towards left side poly. Okay, escape, check and save. Just run the DRC again. Assura, run DRC, apply. Okay, yes. Yeah, here we have got the error. Poly to gate spacing must be 0.12 micrometer. Let's see. Yeah, it should be 0.12 micrometer. Press A, right click, user spacing 0.12, hide, make this partial select this edge with respect to this. Okay, right now it is 0.12 micrometer. Next error is poly interconnects spacing must be 0.12. We'll see that. Yeah, it was same thing. uh, just say next thing we are supposed to place our contacts. Select contacts, place our, just draw it 0.12 cross 0.12, give, make it 0.12 cross 0.12, apply and okay. Okay, and as we are no, just move it up. As we are known, in last video only we have seen the spacing between our oxide edge to this contact edge is 0.06. Okay, select this contact, make it 0.06. Okay, the side, select this edge, it is 0.06 and this spacing should be 0.1. Sorry, press A, options, make it 0.1. Side, okay, select this entire contact, it is 0.1. This spacing should be 0.06. Again, make it 0.06. Select this edge with respect to this. Now we have got, but we have done here one blunder, that is this is the terminal we are going to take it as a common. Okay, so for that the contacts must be placed in this region also. For that we are supposed to just we'll do one side first. Select this, copy F3 and make it spacing of rows should be 10, column should be 1. Make Y spacing at 0.14 because the contact to contact spacing must be 0.14 in 90 nanometer technology. Step should be 1. Apply. Okay, so here we have got this contact. Just move this downwards. So align it over here. Okay, just select this bottom 3 and delete. These are the extra. In similar fashion we are supposed to do top side spacing and bottom side spacing same. Okay, it is 0.06 top side, it is 0.26, it should be 0.16. Okay, for each side. Select this entire contracts, press A, right click, make it 0.16, hide, select this edge respect to this. Yeah, it is 0.16. Right now it is symmetry. Next thing we are supposed to place these same contacts in between these polys. Okay, for that we are supposed to move this, press here, okay, we'll select this contacts, press C, F3, make it keep copying, rows should be 1 and hide. Yeah. Done. Okay, right now we are going to set as we are known the spacing between poly to contact is 0.1. Press A, make it 0.1, hide, select this edge with respect to this. Yeah, it is 0.1. And in similar fashion select this poly, press A, select this edge with respect to this. Yeah, it is 0.1. Now it is done. Next thing we are supposed to copy this all contacts downside, right side. Just press C and copy to right side. Okay, escape. Just select this all contacts and make it spaced at 0.1. Okay, already it is 0.1. Yeah, select this edge with respect to this. Okay, for this edge make it 0.06 spacing. Okay, with respect to contact, press a options, make it 0.06, hide. Yeah, done. Right now it is we have created our all the terminals, because as you can see in our schematic, this both the terminals are common. Okay, that's why we are going to make this terminal as common. This is going to act as a source, this is going to act as a drain of this transistor, this will be drain of second transistor, this will be common source. Okay, so next go to search for P implant, but this is a PMOS. Okay, press R, just paste it. Okay, escape. As we are known, the spacing between P implant is to oxide is for a for this upside it is 0.1. Let's say go to options, make it 0.18, hide. Yeah, it is done. For downside also. Yeah. Next, this is 0.14. Okay, has to be 0.14. Yeah, done. And poly to oxide spacing must be 0.18. Okay, just align this options, make it no spacing, select this edge with respect to this, it is aligned. Yeah, right now it is aligned. Next thing, we have to draw the ear, yeah, ear tap. Okay, ear tap is going to draw for the PMOS, and P tap is going to draw for NMOS. Okay, for that select oxide, press R. Okay, draw in such a way that it should be aligned with your P implants. Okay, while doing abutment, it will be easy for us to do the abutment. Okay, press A, select this edge, respect to this. We will be looking into abutment also, how the abutments are going to be done. Abutment in the sense, many of the cells are going to kept adjacent, so there should not be inefficient way. Okay, not just placing the adjacent to each other. That should be in efficient way. There should not be any DRC error, and all the DRC errors should be cleared. So next thing, you are supposed to draw the contacts. Okay, just select this contact, press C, just copy this over here, done. And see the what is the spacing between this and this. It should be 0.06, because we have aligned our ODs. Next, same for bottom row, go to here, user spacing, make it 0.06. Okay, select this edge with respect to this, even for this also. Okay, done. Just select this contacts, copy F3, uncheck this, spacing should be 0.14 for x direction, 0.14, and apply. Sorry, undo, press C, select this item, contact, sorry, press C, F3, make it 0.14. Yeah, column should be, make it 10, and apply. Hopefully, yeah, we have to add one more. Okay, press C, F3, make it 1, and keep spacing. Copy, hide. here. Make this distance at 0.14. Options, make it 0.14. Yeah, it's done. What is this spacing? We have got here 0.1 and here it is 0.06. It means 0.16 total. It has to be 0.08. Okay, just like this. Make it at 0.08. Options, make it 0.08. Yeah, it's done. Right now we have to cover this entire OD layer with metal. Okay, over here select this metal, press R, select this edge. Yeah, done it is, and it has to be implanted with N implant. Yes. Okay. And as we have seen in our last video, the oxide to N implant spacing must be 0.02. Options, make it 0.02. Hide, select this edge. Already it is 0.02. Yeah, it's done. Escape. Now we are going to see what is the spacing between our OD to poly. Okay, for that check and save, and I run the DRC again. Yes. Okay, now they have given poly to oxide spacing must be 0.1. Let's see. Yeah, it should be 0.1. Press A, options, make it 0.1. Yeah, it's done. And next thing they have given it as P implant to N implant spacing must be 0.16, but we'll see that. Right now we are supposed to draw our N well. Go over here, select this, press R, and draw the N well for tap cell as well as our MOSFET. Okay, draw over here, and now we will be seeing what should be spacing between our N well to oxide. Check and save, run the DRC again. Okay. Yes. Yeah, they have given that LVL to N implant oxide enclosure must be 0.12. It should be 0.12. It should be 0.12. Yeah. Press A, right click, options, make it 0.12. Hide. Select this edge with respect to oxide. Okay, 0.12. This has to be 0.12. Okay. Next error is not visible. Okay. It has to be 0.12 again. Select this edge. Yeah. Right now it is hopefully for PMOS or DRC should be clear. Apply. Okay. Yeah. Just forget about these errors. These two errors, we'll be looking into that forward. Next thing we are supposed to do our NMOS. Okay. Just select this entire theme, whatever we have drawn over here. just copy this downside. Okay, just press C, F3, yeah, it is 1 1, keep copying. Yeah, select this edge, copy this downside, press done, escape. Right now we are supposed to extend this poly downwards, stretch this poly downwards, press yes, select this edge, done, do the same way, and uh, just implant it with your type. Press your implant, just press R, okay, and just click over here, yeah, the spacing between N implant, top side N implant to oxide must be 0.18, make it 0.18, hide, yeah, for downside also 0.18, and for right side and left side it should be 0.14, make it 0.14, hide, yes, it is done, 0.14. We have to align our poly with our N implant, okay, select this edge, go to this aligned, in similar fashion this has to be aligned with this, okay, done, yeah, then select our tab cell, okay, just select this, yeah, it's selected, copy this downside, except implant should not be selected because here we are going to change implant, it should be P implanted, okay, escape. As we have seen in here, add here, the spacing between our poly to oxide should be 0.1, okay, just keep it at 0.1 distance from poly, okay, line, make options, make it user spacing 0.1, hide, it is done. Next, implant this with P type impurities, just choose P implant, press R, okay, yes, and the spacing is 0.02, align, options, make it 0.02, hide, okay, okay, yes, it's now done, and yeah, we'll see whether there is any error we are going to see or not. Apply, okay, yes, yeah, there is no any error, it means DRC is clear. This is a efficient way and faster way to design any layout from scratch, okay. Next we are supposed to give the our contacts, okay. So for gate terminals, for, this will be A, this will be our A terminal, okay, yeah, this will be our A, and this will be our B, yeah, this will be our B, and we'll see if I connect this one, this will be common source for both PMOS, this will be common, this will be drain of PMOS 1, this will be a drain of PMOS 2. Next thing, go to schematic, yeah, drain, are also getting shorted, and those are given to one of the drain terminal of NMOS. Okay, so both of these should be shorted. Let me draw. This has to give on to this drain terminal of NMOS. One this has to be shorted like this and connected over here. Hope you got this. This both drain has to be shorted with metal one and given that input to here. Okay, and in similar fashion this has to be connected. Okay, if you don't because here the source and drain are connected. Source of NMOS 1, NMOS 0 and NMOS 1 is connected. Okay, so here source and drain are connected, just connect it. If you don't connect also it will be okay. And next this will be your source, and source is connected to ground. Okay, VSS, and this terminal has to be connected to VSS. Okay, hope you got this. If you didn't, please re see again. Okay, next thing we are supposed to just connect this. Select the metal, press B, select this terminal, go over here, enter. Okay, just align this with contacts. Select this, align, make it spacing as no spacing. Select this edge with respect to this one. It is aligned. Next thing, we are supposed to connect this, right? But in between this, we are going to get our gate connections also. Just press shift here so that. Okay, select this entire thing and stretch it down. Press yes. Yeah, it's stretched down. Right now we are supposed to create our gate contacts. Okay, for that select metal one, press R. Should be from here. We'll see what is the spacing between our metal to oxide. It is 0.1. Right. Okay, similar fashion, copy the contact, copy this downwards, move this, escape, select this, move this here, done. Just align this with this, uh, save and run the DRC. We'll see whether there is an error we are getting or not. Run the DRCX. Okay, metal to contact enclosure opposite. Yeah, see, we have not got any error regarding the spacing between oxide to metal, but we'll see once what it should be. Just move this upward. Okay, and save and run DRC again. Just apply. Okay, yes. Yeah, they have given poly contact to oxide spacing must be 0.12. Where it is, yeah, it has to be 0.12. So press a option, make it 0.12 user spacing. Okay, hide, select this edge. Yes, it is 0.12. Already it was 0.12. Next thing, they have given that it should be 0.06. Okay, select our contact, make it aligned at 0.06. Hide, select this edge with respect to this. Yeah, it's done. Next thing, copy the contacts at 0.14, F3, uncheck this keep spacing, 0.14, make it as 3 column, row should be 1, and apply. Ester. In similar fashion, it has to be 0.06 spacing between this metal to our contact. Okay, right click, options, it is already 0.06. Select this edge with respect to it is 0.06. Okay, done. Next thing, you are supposed to select this entire thing and copy, press F3, make it to 1, keep copying, hide, copy this in this fashion. Yes, it is done. Escape. Yeah, right now our gate contacts are done. Next thing, we are supposed to do the routing. Okay, for that we'll see what should be the spacing between our this oxide with our metal gate contact. Okay, just select this and just align this with at 0.12. We'll see options, make it 0.12, hide, select this edge with respect to this. Hopefully but here we are going to get our routing also. We'll see what's the spacing between metal to metal. Just route this, press P, select this drain of PMOS and just connect it over here. Just press enter. Okay, align this with our contacts, select this, align, spacing should be no spacing, select this edge with respect to this. Yeah, it's done. Next thing, we are supposed to connect this PMOS drain with our this PMOS drain. Okay, select this, okay, just press enter. You'll see what should be spacing between metal to metal. Just align this, select this edge, it is aligned. Next, again draw the P metal, press P, sorry, press P over here, try to draw over a P here, center. Okay, now we'll see what should be spacing between this metal to this metal. Just save and run the DRC again, apply. Okay, yes, yeah, they have given metal to metal spacing should be 0.12. Okay, now make it 0.12. Yeah, it should be 0.12. Select this metal and align it at 0.12. is just spacing, it is already 0.12. It is aligned and just stretch this metal downward. Okay, done. Okay, next thing, we are supposed to just stretch this towards upward. Entire thing has to be stretched upward. Okay, sorry, stretch this upward. We'll see what should be the spacing between our metal to oxide. I think it is 0.12 already. We'll see once more. Okay, select this entire thing, stretch this upward. Keep your oxide as close as possible to your metal. Okay, it is done. And save your layout design. And also we have to connect this, but we'll see that afterwards. Run the DRC, apply. Okay, yes, excuse me. Okay, they have not given any DRC error regarding this. What it should be, how much it is. If I try to measure this, it's 0.25. Yeah, try to merge this. Okay, move this upward. We'll see, but I'm selecting this also. Move this upward till here. So 0.12, okay, and just select this entire thing. Even this also has to be moved upward, okay. We'll see. And where we had drawn this one should be at. Move this bit downward. It should be at 0.12, okay. Make it at 0.12. You just spacing. Select this edge with respect to this. It is 0.12. Yeah. Even here we are going to get our make it select this entire thing. Just stretch it downwards. Okay. Stretch this. Yes. Right now we are supposed to draw our metal contacts, okay. For that, just move this downwards and keep it at the distance of 0.12. Stick to this, okay. Yeah, it is done. Next thing, even here we are going to draw our metal, and this spacing must be 0.12, okay, from oxide. So for that, just press P and draw the metal contact. Yes, it is done. Sorry, here we are supposed to press enter, okay, and just chop this metal. Shift C, select that and press Shift C. Yes, it is chopped. Next, press P again and connect this source terminals of NMOS. Okay, go over here. Just draw the path. Go till here. Press enter. Poly has to be aligned with our N implant. Okay. For that, align to here options. Make it no spacing. Hide. Select this poly. Align this with this. Even select. Sorry. Yes, it is aligned. Next thing, we are supposed to make this contact edge to this contact edge is spacing must be 0.12. Okay, so select this all, just align this at 0.12. Okay, this user spacing, select this edge with respect to this, it is 0.12. We will see whether we have done any, yeah, it is blunder over here. It has to be stretched till here, till downside. So stretch this. Yes, it is stretched up. Press F. Right now we'll see if there is any DRC error we are going to get or not. Run DRC again, apply. Okay. Yes. Yeah. No DRC error we have found here. Next thing, we are supposed to create our pins. Okay. So for that, uh, just close the DRC error found window. Okay. Just go over here. Create pins. what are the pins we were created? VDD, VSS, A, B and our Y. Okay, just display terminal names. Check this display terminal names. Here height should be 0.06 and this has to be metal 1 label. Okay, and height. Okay, go here. This is our VDD. Sorry, go over here pins. Sorry, again we have to do. Yeah, okay. Height. Just click over here, drag, click over here. This is the VDD. Downside we are having VSS. This is VSS. This will be A. This will be A. This will be our B. So this will be our Y. Okay, here we are going to get our Y. Yeah, it's done. Now we'll see if there is any error we are going to get or not. Okay. Yeah. Just save the layout design and run the DRC again. We'll see if there is any DRC error we have found. If it is so, then we will fix it. Okay. Just Assura, run DRC, again apply. Okay. Yes. Yes. Yeah. No DRC error is found. Next thing we are going to run this LVS. Okay. Assura, run LVS. See over here, library should be same. Sales name also same because we have given cell name as same. Okay. We should be schematic for uh, up library. For down library it has to be layout. Okay, technology 90nm, just apply. Okay, yeah, it means our LVS and ER schematic is matched. Okay, so this is all about how to draw our NMOS NAND gate layout. Okay, 2 input NAND gate. Next thing we are supposed to align this. We are supposed to create our PR boundary. Go to create PR boundary. Okay, and yes, for abutment it has to be aligned with your implants. Okay, implants will be abutted. Sorry. Yeah, but we'll cover all the things. Okay, here select this. Yeah, escape, move our origin, edit, advance, move origin, keep it at center. Yes, align our PR boundary. Let's say options, make it no spacing, hide, align this with this, aligned, and this has to be aligned with row origin. Okay, has to be aligned with our anvil. Sorry. Yes. So this is our NAND gate. Okay. Uh, this is all about, guys, today. If you are having any doubt regarding the NAND gate layout, you can post it into the comment section. So we'll see next video how to draw the NOR gate also, 2 input NOR gate, and we'll do many things in this playlist video. Okay, and so take care, guys, till next video. Goodbye. Thank you. Thanks all.